This study is a great example of lesion tracking through time. So here we have 4 time points, and we'll be able to do SUV comparison. This is a lutetium 177 PSMA study. So 4 different time points, looking at coronal and MIP for each of the time points. These time points were co-registered on the fly when I loaded the study. It takes about less than 5 seconds to register all 4 time points, and our registration algorithm is very fast and very good, which makes it uh, very easy to do comparison through time. Uh, this is a SPECT CT. Uh, we're not looking at the CT portion here, but the SPECT CT reconstruction was done using our own hybrid recon reconstruction. And because we calibrated that camera for lutetium, we're now able to get SUV values present here in the study and get values to be able to compare 2 different time points and scale the study properly as well. So let's identify some lesions. So again, we'll try to do it via the single click segmentation. So we're using an SUV threshold, the same one for all 4 time points. So I'll have to scroll through, find my lesion, 1 click, then I get my first lesion identified here. I can go straight to the second time point, 1 click to activate it, and then 1 click to create a lesion volume. And I can repeat the process for the different time points. And now I have all my segments here. So I have one lesion in the 4 time points and a smaller one in 3 out of the 4. I have all my statistics here available at the bottom for each of those segments. I could rename them if I wanted to. And if I go to column charts, that's where it becomes interesting. So right away, because I've identified more than one lesion in each of the time points, except the first one, but still it sees it as 4 different time points with multiple lesions, it goes into comparison mode. And this mode, the software will use some AI to identify each lesion, its position, its size, and compare it to different time points and associate them together. So we can see here the dates at the bottom, so the 4 time points here. So the lesion that is part of the 4 different studies is first here on the left. If we go to SUV max, for example, then we'll see that the SUV max for that lesion has been identified, and there's a percentage of evolution through the different time points. But the software knows that these 4 lesions go together, and then these 3 lesions go together. And that is achieved with the AI program that we've integrated into the multimodality viewer. So that's great. We can get a nice comparison. We can do it for multiple values, even volume. If we go to size, now we're looking at volumes of the different lesions and the evolution over time. Again, you can create screen captures of this. You can make a nice display where you have up and down or left and right, the graph and the statistics, and you can export those as well to Excel. But it makes a nice and easy comparison tool. Registration is done very quickly. Creating volumes of interest is very easy. And then you have the graph in comparison mode that makes your life even easier when you're trying to compare the lesions together. And let's not forget that we have all these nice SUV values because of the SUV SPECT reconstruction. So now I'm done with this case. If I want, I can save a nice screen capture of the entire screen. It's now added to my data tree, and I can save that to a USB stick, or I can export it to your main archive. And that's it for this case.